Hello, everyone. Good evening. Yeah. All right. So I'll just start sharing my screen. You can hear me, right? Okay. All right. So welcome to the fifth live session of the course Foundations of Our Software. And so we are done with the 4 sessions. And I believe by now you're all familiar with how this is going to go. And you've probably already installed R&R Studio. So this is there. This was just basic placeholder slides. All right. So before I start with whatever's been planned for today, do you have any questions? Anything about the previous 4 weeks? Anything about the course in general? Any feedback you would like to give, especially pertaining to the live sessions? Anything? Okay. So if there is nothing, then we'll just start with the session. So in this week, there were mostly two, like broadly two topics that were discussed. One was missing data handling, and the other one is if and else conditional statements, right? Last 4 classes. Okay, you have the so if you take a look at the course, you would see that you can find the link to the last 4 weeks videos of the live session, right? That's what you're asking, right? Yeah. Okay. All right. Okay. Yeah. So those videos are there. Anytime, any doubt, you have both the course videos and the recordings of these live sessions. So, yeah, anytime. Yeah. Okay. So the first of the two topics that was discussed is missing data handling. Okay. So, let's take a look at some examples. So, and there are three, one second. That's okay. So the videos, you're talking about the lecture videos or the problem solving session? Assignment 2. Okay, these questions we'll discuss today. All right. Okay. Anything else? So yeah, so again, these live sessions, they are not the attendance in them, and actually even watching them on YouTube is not uh, essential or mandatory with respect to the course, because you're not being graded, or that's not a requirement for the course, but this is just for your help, just for your benefit. Okay. And any questions you have anytime, so these live sessions, also from any of the previous assignments, so usually assignment 2 and 3, these questions we'll discuss today. All right. So we'll try and finish off today's discussion. Log of any other value. Yeah, so I completely forgot about that. I will we'll take a look at that today. And okay, so I'll start off with the session. Okay, so we start off with these with missing data value. So let's say, and okay, before that, there are 3 types of data, or 3 types of variables that we are mostly going to work with. The first one is a single value. It could be an integer, it could be a decimal number, it could be a character. So that's a numeric or a character type, but a single value. The second kind of data is a list or a vector, a data vector which has multiple values. And the first value has an index 1, then index 2, and then so on. And finally, there are matrices. Matrices are 2-dimensional. So first you talk about the number of rows in that matrix, and then you talk about the number of columns. Okay, so we'll talk about missing data in any of them, in all 3 kinds of things. So when we say for the single value variables, so I will, so again, if my cursor is here, I'm going to press Control Enter. And then this line is basically going to get copy pasted below here in the console, and it's going to get run. Okay, so it's going to be executed. So I run this, it's executed, and you get a value of 4 for A here. Likewise, I run the second one, I get a value of NA for B. Okay, so here you are able to take a look at it. So you can directly say, yes, NA is it's in B. And so there is a way to check in case if some of you are doing it on the console, this pane is hidden actually, right? You cannot see this. So for that, there is a function called is.na, and it's a function, it's an R command. So is.na, and then you have the curved brackets, and you inside that curved bracket, you're going to write whatever variable it is that you would like to find if it is NA or not. So here, when it's a single value A, if I run this, it's going to give me false, because is A NA? No, A is not NA. A is 4. So it's not NA. So an answer no, or it's not, it gives you false. So these functions give you an answer true or false. Yeah. So NA is, we'll see what NA does. Okay. Actually, let me okay, since you've asked this, okay, so let me tell you length of NA. Okay, if I try and do this, it has a length 1. Likewise, if I do length A, right, length A, length B here, so NA is a number, but it is not 0. So the thing is that sometimes you would like there to be like, it's a missing value. Something happened, let's say you're taking some readings, and it says error in the device. So would you say that the value is 0? No, right? Because it was a device error. Now you can't, let's say you have 10 samples with you and you're running them one by one in the device, and for maybe the 6th sample, the device showed an error. But all the for the other values, it gave you some numeric values, 10, 20, 5, 10, 11, 6, and so on. But for that 6th value, it gave you an NA. But now you can't say that you are making a table, you are entering it into Excel, right? You're documenting it. You can't call it 0, right? Or you can't call it any random value. So as a placeholder, when you're writing it in your copy, you would probably just write error, or you put a dash. It's like it's a placeholder, so as to say, because you're just saying some value should come there. But as of now, we don't have that value. It can be number, it can be a character. These are the 2 types we have discussed till now. So NA could be any of them. NA by itself does not have a type. It is NA is NA type. So for example, there are these functions like is.na. There are also is.numeric. So if I write is.numeric A is 4 here. So what do you think it should give me? This is explanatory, right? Is.numeric. So you're asking if whatever value we entered inside, is it numeric or is it not? So what is it going to give me? It should give true. And it's good you've written all of it in uppercase. So yes, so it's going to give me true, right? But let's say if I write is.numeric B, B holds the value NA, it's going to give me false, right? But is.na is NA is a type in itself. So is.nab, this is going to give me true, right? So NA is a placeholder, right? For placeholder for missing values. Okay, right? So this is when we are talking about single values. A and B has a single value to it. And now, likewise, we can have vectors. So X, so just all of you for a quick recap, what is going to be the value of X? How many values are going to be there? And what are those values going to be? Yeah, so it's going to be 3, 4, 5, 6, 7, 8. 6 values. Okay, so I'm going to run this one. So you can see here, it tells you it's int 1 to 6 indices. These are the values. And C combine command also does the same thing. It's just that now you can specify values that are of your interest, any value. So I have this. So here also I have 6 values, and I've entered 2. Let's say 2 of them are missing. My device it threw an error twice. Okay, so now if I do is.na, it is going to check. It does not make sense to check it for the whole list at the same time. It will do it element wise. It will give me an answer for each element. So if I run this, I'm going to get a list. The output is also a vector of 6 values, each of them being true or false. And the first one is -1, so it's not NA. Likewise, second one, X, this one, 3 to 8. So all of them are false in this case. All of them are not NA. But now if I do this one here, if I run is.nay, so now you can see the third one gives me, I get the third value true, and I also get the fifth one as true. So 2 of them are NA. That's fine. Now, so now there is an important aspect, which this is later discussed in the last lecture of this week. And by the way, just mentioning again, these live problem solving sessions would be more useful if you have already watched the videos, right? Because I am explaining all of this quickly. So it might be confusing if you're taking a look at it for the first time. Although I hope you've already seen it, because the deadline for the assignment is tomorrow. So don't wait until the last day. Because as I've seen in the past 4 discussions, we also learned so much in these solving sessions, right? So we can always have longer discussions on newer things, but I'm not going into very details of what's already been discussed in the course, right? Okay, so there's another function which. So now you understand here what you've got is you've got some true or false, right? Now, which function, if so, there's this thing question mark and the function name. This is a very useful provision that R gives us. So if I take this, it's going to open a help window here. And so multiple options are there based on, I have like extra packages installed, but here we are mostly interested in the base package. This has not been discussed extensively. It will come up in the later lectures. But anyway, so I'm opening the first one here. So basically, the which function, the which command, what it does is it gives you the true indices of a logical object. Now read this line slowly. So the object that you're giving it should be a logical object. It should be either a single true false, or it should be a list of true and false. That becomes a logical object. And it will give you the indices of wherever it's true, right? So, and you can understand. So which is also sort of intuitive. What would you be normally interested in? Which of these they, fit into a description? Which of these make sense? Which of these follow this rule? So which of these are true? Basically, simple. Which of these are true? Absolutely correct, right? So now, so what we are doing is, now this is an example of a nested command, right? So you have multiple, these parentheses one inside the other, right? This is not the first time you're looking at such examples, but I just want to iterate it here. So this is one task. This is what we saw the output is going to be, right? False, false, true, false, true, false. And you're feeding that here, the inside of which is actually this list, this vector. So when I run this, it's going to give me 3 and 5, because what is the indices of the trues here? It is 3 and 5. All right. Now, can you tell me, if I do, okay, I'll ask you the question later. So now, so now again, this one is a list of true and false. So there are two common things that you can do on a list of true and false. One is which. One is where you are finding the indices of the truths. The other thing you may be interested in is knowing how many truths are there, right? So here from this list, I can get, like, by looking at it, I got two informations, right? There is a true at the third position, there is a true at the fifth position, and in total there are two truths. So how do I get each of this? So the first one is giving me the indices. Like one of you rightly said, it's 3 and 5. And this one is telling you how many truths are there. So I'm doing sum here. So, and sum is giving me 2. Now, can you tell me, so normally we have seen that if I want to find the length of something, length of, let's say, x, so this is going to give me 6, right? So I have some, so why not we use length of is.na, right? I did not get why the answer was 3 and 5. It was the index places for the elements, right? Okay, so now tell me, so I want you to take a look here. I'm writing which, and I'm making a vector with true, false, true, false. Okay, we can do this, right? I'm just making a vector of true and false. So the which command tells you the indices of the truths. That's it. Which command, inside of it, it takes list of true and false, and it tells you at what positions are the truths. So, sorry. Right. So, Divya, can you tell me what do you think the answer for this is going to be? If which gives you the indices of truths and false. Sorry, of the truths. Indices of truths. Yeah, that's fine, right? So here it's going to be 1 and 3. Now in this question, what this inside the command inside of it, this expression, this was evaluated to false, false, true, false, true, false. And this is given as an input to which. So now how do you interpret this line actually? That y is an input to is.na, right? And the output of is.na is given as the input to which. Yeah. Can you see this line? So y, wait. Yeah, I hope this is visible now. So what this line is doing is, so y, so anything inside the bracket is an input to the function that's right outside the bracket, right? This is your function and this is your input. So y is the input to this is.na function. It gets evaluated. It gives you an output. This is that output. And this output is then fed to the next function, which is the outside function here, which is which. So which takes these things, and what does which do? It gives you the indices of the truths. So it gives you 3 and 5. All right, can you confirm if that's okay? Yeah, again, so like in BODMAS, if you have multiple brackets, you solve the innermost bracket first and then you go outside. That's the same thing here. And if any of you have I've worked with HTML, there's this in the greater than less than sign, you have a lot of opening and closing terms. I'm forgetting the exact name for that, but it said that if you open multiple things, you have to close them in the opposite order, something like that. So just relate to it. But okay, I'm assuming this is clear then. If any confusion, please ask again. No worries at all. Yeah. Okay. So now is.na is giving us a list of truths and false. So from that list of truths and false, you can do two things. One is you would like to find how many truths are there. And the other thing is you would like to find what positions are these truths at. what is the indices. So this is what we did. You gave it a list of trues and false and you said which. So it gives you some. Okay. Now, if you feed the same list and you do a sum, so why is sum working here is that internally, true has a value 1 and false has a value of 0. You are familiar with the binary system, right? Binary takes in just two values, 0 and 1. 0 mostly indicating a no or a false or a baseline, and any positive signal or a yes or a presence absence sort of a thing. So that's true. That's 1. Okay. So 0 is like false and 1 is like true. So that is why now you imagine you are summing up 0 plus 0 plus 1 plus 0 plus 1 plus 0. That's why it's giving you 2. That's why you are summing this up. Right? So is dot na, and then you are feeding this like this. Okay? So likewise, like the previous example that we took here, this one. So what I'm doing is I'm doing a sum of this thing. And this is also going to give me true, right? Because 1 plus 0 plus 1 plus 0. That's also true. If I change it, like this, so there are 4 trues, or I just add one more, it's 5 trues. Okay. Now, can you tell me, what do you think this is going to give me? Is dot na gives us this list. What is length of this list? 6, right? So this you need to be careful. This is going to give you a length same as that of y, right? Because whatever was the length of y, that is how many trues and false you're getting, right? It gives the total number of output of it. Perfect. That's the correct explanation, right? And can you tell me what is this going to give us? So let's see it one by one. If you can do it like mentally, well and good. But let's do it step by step. So now this is an example of 3 commands, one within the other. You can write it in 3 different lines also. You can save the output of the first one as, let's say, variable A. You give that to the second function. You save that output as B. And you give that to the last function. Save that as C. But over time, once you get the hang of it, you might like to write it in a single line, right? You won't want to write it in 3 lines. So again, we'll evaluate it one by one. So this one is the first one, right? So is.na, that's going to give us a list of 6 values, trues and falses. Okay. Now, what is this going to give me? We just saw this, right? This is going to give me the indices of trues. So this gives us 3 and 5. What is this going to give me now? Sum of 3 and 5? Yeah. Sorry. This one. Is.na giving trues and false, which giving me the indices of the trues. So yes, so sum is going to give us 8, right? So let's just try that, 8, right? So this is what we actually wanted, right? We wanted to find the number of trues, and number of trues is we find how many trues are there. That is, we have a list of true and false, and yeah, so this one is giving us the value 2. Can you tell me, there is one more way in which you can find the length, in which you can, that will evaluate to 2. That means there are 2 trues in our data. So this one is for getting the indices. Just the spelling. Yeah, getting the indices of trues, right? And then when this is getting the number of trues. There is one more way. Can you tell me? Can anybody think? So here what it's doing is, we're taking the sum of trues and false. So sum of 0, 1, 0, 1, 0, 1, and so on. There's one more way. So which of the things here can you see that have a length of 2? That's the hint. I actually gave the answer. Which of the things here that you see actually has a length of 2? Any idea? Anybody? Give it a try. Is the question clear? Okay, fine. So what is this giving us? What does the 2 indicate here? This indicates that so basically I wanted to find the number of NAs in the initial question, right? I wanted to find how many NAs are there. So one way of doing that was I evaluate is dot NA and I feed Y. So I get true, false, and so on. And then what I do is I do a sum of is dot NA. So I get 2 because it's adding up 0 plus 0 plus 1 plus 0 plus 1 plus 0. This is what it's doing. Now, we also saw one more thing. So which is dot NA Y, right? So what is this going to give me? It's going to give me count. So R instead of count, it takes length. So length of this thing, that's also 2, right? So either you sum this up or you find the length of this, right? They're both giving us the value 2, which means counting the number of NAs. That was the idea, right? Okay. And these two expressions, as we saw, these are not giving you the right thing. This is something else. So you have to be careful at what you are evaluating. So even when you are not doing it on R itself, or even when you are doing it on R, you should evaluate it, try and evaluate it manually, see if you've understood correctly and see if that's what the answer is. So once you check that, then with practice, it's going to get, you'll get more comfortable at making slightly complicated commands like this. This is not absolutely essential with respect to the topic, but this is what these live sessions are for. We'll just slightly go into maybe just a little bit here and there so that we can cover more. Okay. All right. Now, where we were initially is that we were saying we were interested in finding the indices or the values that are actually NA. But what if you are interested in the non-NA values, which also makes sense, right? You need not to be like, it's good to know what NA is, but in reality, you would like to actually know which ones are not NA. So there are 2 ways of doing it. So one way is using the same thing, but you remember what can we use to exchange true with false and false with true? Do you remember there was one, just one key from your keyboard that is going to be used for that? So that's what we want to do, right? Right now we are getting trues for these positions. Now, if my question changes to which of these are not NA, then I would like to get a true on these positions, right? So do you remember what expression, what expression, what symbol is used to exchange trues and false? Is dot numeric, that is correct. That is actually correct. But let's say if it was a mixed list of numbers and characters, or if you are not interested in, if it was a mix, that's right. So you're correct. For this one, is dot numeric is going to give us the same answer as what this exclamation mark is going to give you. So that's what I was looking for. So this thing, right? So I'll just clear this. So is dot NAY, it gives us this list. And if I just put an exclamation mark at the starting, This is important. You need to put it at the beginning. If I do that, now you see these trues and false have exchanged. They've interchanged, right? True becomes false, false becomes true. Because that is what exclamation stands for. It stands for not. So you are basically comparing. So what this does is, so you are actually, so not basically does its opposite. Not equal. Yeah. So when you're doing exclamation is equal to, that stands for not equal. The exclamation itself stands for not. So not, or if you have studied in terms of the not gate, so this just exchanges. It becomes true becomes false and false become true. Right? So it's basically, so what internally it does is that it's comparing, it's asking which of these are not true. Right now, think about it. Is this not true? That means basically it's comparing each of these to false. Right? So this one is not true. That's correct. That's why you're getting true. This one is not true. So true. This one is not true. So it's not false. Right? So therefore false. So, but that's complicated. So basically what it does is give you the opposite of it. All right. Okay. And there's one more way which gives us the same thing. It's complete dot cases. So complete cases basically means which of this is a complete thing, which is not a NA. So if I do that, that's also going to give me the same value as what I got with this one. So these are both giving us the opposite of NAs. Which of these values are not NAs? Okay. Now, okay, so that's fine. So you can find the indices of NAs. You can find how many NAs are there. And you can also do the same thing for the opposite ones. If you are interested in how many of them are not NAs, how many of which positions are the NAs not at, which of these have full numbers or characters at them, you can make a combination of these, one or more of these functions. Okay, so that's good. Now let's come to the next bit. So these NAs, now like we discussed, these NAs are not zero. Okay, so had there been a zero in their place, it's fine, you can take a sum. So what you do, if it's 5 plus 2 plus 0, you just ignore that 0. So it's 5 plus 2. But of course, that 0 is a number, right? It's there. So especially now, think about it this way. So can you tell me if I write this thing and I write this thing, and likewise I write this and I write this. Okay. Oh, I should have put a comma. Yeah, okay. Actually, what we discussed the last time, this one's better. Just to be clear, you should always enter vectors to these functions. Okay, right. So this is what it is. So what's the answer to the first one? That's 7, right? Let me put it here. Yeah. The answer to this one is also 7. That's okay. Now, will the next two be the same or will they be different? Line number 39 and 40. Will the two ones be same? Yeah, so I have put a C here. Right, so you're right. So this one. Mean. Yeah, so not 7. This is mean, right? Average. So mean of 2 and 5, that is 3.5, right? Because you have two numbers. What is mean? You sum them up and you divide by the number of numbers. So here you have 2 plus 5 divided by 2. Here you have 2 plus 5 plus 0 divided by 3, right? So 0 being there or not being there is a difference, right? Think about it in this way. You are calculating the, you have some device, again, some measurement you are taking. So getting a number 0 in it does not mean you can ignore it. It is also an observation, right? So mean will take that into account, that you got a 0 in one of the observations, so your average is going to get reduced, and this makes sense. But now, what about NA? So we saw it here, that NA is a placeholder. It is not 0. Okay. So now, likewise, so again, I'll just remind what is X and Y that we have here. So X is just a list of numbers. So like we gave it here, it's going to give us a list. It's like going to give me a mean. It has the own sum, it takes mean, and for mean, it's going to take this length of 6 for X. Now, if I say I want to find the mean of Y, so now it has NA values. So what do you think, if you were doing it manually, what would you do with NA values, right? If you have this one, this is what you have. What do you think, according to you, what should the mean be, and why? Can one of you tell me what you would calculate? I don't need the answer, like the final number, but how would you proceed with it? Y mean? Okay. So what is the formula for mean? It is sum divided by number of numbers. So this here you are dividing by 2, and for this you are dividing by 3, right? Yeah. So in sum, it doesn't make a difference because you're adding. So adding 0 does not make a difference, but 0, the presence of 0 is an additional number, right? Yeah. So now, where were we? Yeah. So imagine this is a list that you've got. Can you tell me, if I give it to you manually, forget anything about R, if I just give you this list and I tell you the device stopped working twice, I don't have those observations, what would you recommend me to do? If I have to find an average, whatever this is, length, weight, height, temperature, I don't know, whatever, absorbance, percentage to name because it's negative, something. Tell me, what do you think, how would you go about it? If you get any, that means if your device stopped working, you omit the NA values. Perfect, right? Because you say, oh, we can't comment anything about it, right? Because, okay, this just shows you that you tried it doing 6 times. It did not work 2 times. So you have observations for 4 of them. Now here you see, there is a 0 here. That's a very valid observation, right? Because whatever your device was, let's say it was a scale, so which gives you both negative and positive values. So it gave you a 0. So that's there, right? You have negative marking in your scores in exams. Anybody can get a 0 if you have done enough negative marking. So that's there. But let's say NA in that sense would mean maybe like a person is absent. So many people were registered for the exam, but 2 of them did not appear. So when you're finding averages, you would like to ignore those values. You would like to omit. Omit is one of the best terms to use for it. Okay. So if I don't explicitly mention that you should omit it, by default, the mean function does not take that into account. So what it does is, it says it says that it's NA. Likewise, when you take a sum also, it gives you NA. So what you would like to do here is, so what you would like to do here is actually you would explicitly mention in that function. And now let's take a look at this function. So mean, if I do question mark mean, it's going to open something here. And now you check. So all of this we'll just skip for the time being. Where is it? This one. Okay, yeah. So can you see this has this option, na.rm? This stands for removing the NA values. So by default, it's false. Whatever you see here in this console, the default, this means if you do not specify anything. So remember we discussed this, that there are certain compulsory or required arguments, right? So for example, the first one here, that's a mandatory argument, right? You can't run mean empty because you need to provide something. So this is a mandatory argument. But this one, it's an optional argument because this already has a default value to it. So the default value is false. That means by default, do not remove NAs. It's actually good that it's not there. So if you're getting NA, you can, be alert that, oh, probably I have some NAs in my data, so I need to check. Although it is a good practice to always check if you have NAs in your data, if you think there could be NAs in your data. Because here, well, you can look at it. But if you have thousands of 1,000 dimension long, 1,000 length something, so you cannot check it. So it's always a good practice to try is.na your whatever your variable is. If it doesn't give you anything, good. So what I'm going to do here, and likewise, I think the sum function should also have something. Yeah, this one, na.remove. This also has, this also has this argument na.remove, and it's false by default. So now what you can do is na.rm, and this will do true. So by default, sum and mean, they both give us NAs. But if I do this, they both give us some values, right? Which is good. Now, again, can you tell me, don't look at the values here, but can you tell me, so when I'm summing it up, I'm writing -1 plus 5, which is 4, plus 0, 4, plus 3, 7, right? Yes, that's where we are coming at. So you have 4 values remaining, right? You have 6, and you summed up the 4 of them because you're saying na.remove. So it's removing. It's not making any changes in the original variable. That's not what it's doing here. But it's making changes in while calculating the sum, while calculating whatever it is. And here also, so here also it's saying now instead of 6, it has 4 values. So for sum, it summed them up. And for mean, it summed and divided it by 4. So you can also check this here. Initially it was, so the sum is 7 and you divide 7 by 4, you get 1.75. So the calculation is with the remaining numbers, and it's only considering those remaining numbers as its input. Okay. All right. So this is what it's doing. Now, so this one, what it internally is doing, it's actually creating a new vector, right? It's giving you -1, 5, 0, 3. This is a new vector it's created. But you don't have that vector with you. You only still have this. So sometimes you would actually like to, maybe like you would like to say, okay, fine, I have this, but now I would like to get rid of these NAs permanently. I would like to make a new vector. So how are you going to make that new vector? So there is another function, which is na.omit. So what this does is that it's going to actually give you this thing, right? So what you can do is you can now save it in a new variable. You will say y2, let's say. Okay, let's say so normally, like we discussed, if you do not have this assignment symbol, anything that's getting calculated is just getting printed. It's not saved anywhere. But typically, if you would like to, you're saying you want to omit something and you would like to get a new vector, you would like to save it. So this is how you can save it, right? Now you see, this is your new vector, right? And now you can do the same thing on, let's say here, doing it on y, or you can do it on, it's the same thing, right? So these two are equivalent, right? So like we discussed, this nested one function within the other. So na.omit y, this thing, it's the same as y2. So these two things are equivalent. Absolutely the same thing, right? So here what you did for sum was you fed it the original vector, but you said while calculating, you remove the NAs. Here what you're doing, you're feeding it a new vector itself, right? You're feeding it, you're saying remove it, make a new vector, and then you are feeding it to sum. So it's not the sum function that's removing it, it's the na.omit function that's removing values, right? Sum, yes, that is correct, right? So you're giving it some y, original vector, and you're saying na.remove true. So it removes it while calculating. And some y2 here, since you've already calculated, so that's also going to give you an na.omit y here, that is again y2. So yes, all these three things are giving you the same output. Okay, so if I am running this one here, that's also going to give me 7. And likewise, in case of mean, so it should also give me 1.75, right? And it does. Okay, but you can always add this na.true parameter at the end of this. It's not harm. It's not going to harm it, right? It's going to give you, it stays unaffected because now you have already gotten rid of the na values. Okay, any questions still here? Yeah, so if there are nas in your data, you would first like to check if there are nas. So a simple is.na function is used. With that output, you can check how many nas are there, which is how many trues did that give you, and where all are the trues. Once that is known, alternatively, you can also do it the opposite way. You can find out the number and position of values which are not nas. And once you have understood all of this, you would like to do some, if these are numbers, you would probably like to do some calculations. Simple one means like mean or sum. So there, these na values, they create a problem. The session is being recorded, so I will upload the recording. Yeah. So once you have these values, if you would like to do some calculations, normally the NA is going to create a problem in calculations. So you would like to remove them. Either you would like to permanently remove them from your vector and create a new vector like this, or you would like to specify it while that calculation is happening. So then you can use this function na.rm. Now just be careful that you should not exchange the two things. na.rm is not a function like na.omit is. And here na.rm is an argument. na.omit is not an argument within these functions. Okay, so just keep that in mind. I'm going to ask you this question at the end of this today's class. So give me the right answer then. Okay. Instead, while feeding itself, we don't need to put any, right? I am not sure if I understood your question. Which NA? Like put what NA are you talking about? While feeding itself, we don't need to put NA. You mean the original vector that you're making? While entering data? Yeah. So the thing is, sometimes you would like to note, right? Because if I just tell you this, if you, let's say if I've asked you to take 6 observations, I've asked you, you have 6 different samples, you run that device, and then you come and show me these 4 values. I'll ask you, but I had 6 samples, right? The 4 values correspond to which 4 out of those 6 samples, and why did you run it for only 4 samples? Why did you not run it for the remaining 2? So then you can tell me, well, the device did not run for 2 of them. I'll ask you, okay, which 2 are there? You'll tell me, okay, the 3rd and 5th did not run. So that information is conveyed in the original data. When you give it, when you specified NA itself, that became clear that you ran it 6 times. The device did not work 2 times, right? So which is why documentation should be complete. The initial data should always have extra information, all the information. And once you work with it, then you can remove data. Then you can remove it. Okay. So that's going to be my recommendation. That, I mean, you are correct. That's the simplest way, but it leaves out a lot of information. Okay. All right. Okay. So now we'll go to the next part of it. So we discussed these two types of data right now, single values and lists. So now let's go on to matrices also and check if it's any different, if it's the same. It's mostly the same, but yeah, just we'll take a look at that. So we are defining two matrices here, M and N, and I'll just click on this here. So here I've specified the matrix to be a 2 by 3 matrix, right? 2 rows and 3 columns, and this is the data. So I think this data is now, this is by column wise, right? Okay. Likewise, the second one here, this is also a 2 by 3 matrix, and here you have two positions, two elements out of 6, which are NA. Okay, that's all right. So now if I do is dot NA on M, so now you see here, it's giving me in the same shape. It's giving me like a 2 by 3 list. By call is default. So let's just confirm that. So it's actually, you remember, it's not by call, but by row. That's the argument. So by row false is the default. So which evaluates to by call, right? So that's right. Yeah. So by row false, that's the default. Okay. Yeah. So now if I wanted to find NAs from M, this is what I got. So this makes sense, right? That I gave it a matrix, the output is a matrix. Cool. Now, likewise, I do it for the second matrix. Here, I gave it a matrix. I got a matrix. Here, the two of them, which was NA, that I got them true. Okay. So here I am able to see it in form of a matrix. But now, so what we discussed there was we would like to find which all indices are the trues at, right? So if I do this here, this is actually telling me 4 and 5. Now, what does 4 and 5 mean? Can you tell me? So this is this false, false, true, false, true, false. This thing, this gave me 4, 5 as the output. What do you think is happening here? 2, 2 and 1, 3 should have come, right? That is what should be there, but this gives us 4 and 5. So what do you think 4 and 5 is? Let's do it one more way. So 4 and 5 is actually, now if you think about it, what did I give it initially? This thing, right? This is what I gave it, right? Now if I did is dot NA on this thing, on this thing here, and if I also wrote which, this gave me 4, 5. Now this also gives me 4, 5, right? Now can you tell me what has happened? Slightly confusing, but think about it. There was a vector, simple vector. We saw examples with X and Y initially. It's a vector. I say in this vector, which positions are NAs. This is what this command is doing. So it tells me in this vector, the position 4 and 5 has NAs in them. Okay, good. Now I use the same vector and I make a matrix out of it. And when I was making the matrix, I gave it that vector. I said there are 2 rows and 3 columns and you fill it column wise. So by row was false, which means it's filling it by column. 1, 2, 3, 4, 5, 6. So now I do see that these two positions are true here. That means these two are NAs, right? These two are NAs. And here it's telling me in the vector itself. Sorry, this is what I wanted to show you. So here also it tells me 4 and 5, right? So you see, this was element 1, this was element 2, this was element 3, this was 4, 5, and 6. So even when it is a matrix, but this one, the indexes, it's actually returning of the original vector that we used. Okay, now take one more example. So in here in N, I filled it column wise. Now I'm filling the same matrix, 2 rows and 3 columns, but column wise. Right, so you check, this was the original one, and this is the new one. Now you see the positions of NAs in terms of the matrix have differed. Right, when you are taking a look at the matrix, these are different. But the original vector, it had the exact same elements. The fourth and fifth was NA. Right? So this one, and if I write it with O, do you think it's going to give me the same thing or different values? The vector is the same, but the matrices positions are different. Any idea? It's going to give me same, right? Because what, right? So if I run this one and this one, oh wow, what is happening here? Interesting. So this one. So here it gave me 2 and 4. Okay. So now, okay, so I was wrong, sorry. So what it's doing is, so a matrix by default is read column wise. So let's just write it here. A matrix is read column wise, irrespective of how the data was filled. Okay.
Ma'am,
Yeah, yes.
if we would have given by row is true, will it read like
Yeah.
row wise?
So you see, here I gave it by row. Right? So this one and this one, you compare N and O. The starting data vector that we are giving it to fill, that's the same. Number of rows is the same. Number of columns is the same. The only difference is one is being filled by row, one is being filled by column. Right? This one is filled by column. This one is filled by row. But now this one, it's giving me a different thing. And the reason is, it is reading the, so it doesn't matter how it was, it's not exactly the reason that how it was filled, but now you forget how it was filled, but now you see this matrix by itself. So this is element 1 and 2 and 3 and 4 and 5 and 6, because the matrix is read. So the which function actually reads the matrix, or reads, yeah, the which function reads the matrix column wise. So it's calling it, okay, the fourth element and the fifth element. Likewise, this one here, it says first element, second element. Second is NA. Third element, fourth element, fourth is NA. So it's giving me 2 and 4. Yeah. A matrix is read column wise by the which function. Okay. All right. Was this clear? Would you like me to explain it again? Okay. All right. So if this is clear, that's good. So now we move on to something slightly different. So we just saw that this value NA, this is actually like a placeholder. So you say that it has a value, it has a length of 1. A very similarly tasked element is null. Null actually has a length of 0. Now, but the thing is, so let's try doing this. I will make a vector. Let me make a vector Z, and I'll call it A 1, 2, 3, NA, null. Right? So do you think see what happened here. So I gave it 5 values, but it took only 4 of them. It did not consider the last one. Okay. So right now, we will not go into why null is used. So there are times when you would like to make an empty something, empty, just like you need to define a variable, but it does not have anything. It's an empty thing. In those cases, null is required. So it will come up in some of the later classes. Do remind me in case we don't discuss it explicitly. But right now, I would just like to tell you that null has a length of 0. Okay. But NA has a length of 1. So NA is a placeholder. But null means it's absent. It's not there. The position is also not there. So you see what happened here? Yeah. Okay. And can you tell me what this does? You remember what line number 72 is going to do? Nobody. You remember this, right? You can hear me. What is RM? What do you think RM stands for? Remove. And what I'm actually giving it here is this. This is the input. So list is the name of the argument, right? Remember, by row is the name of the argument. Encall is the name of the argument. Likewise, list is the name of the argument. And what is the value of that argument? ls. What does ls do? What does ls stand for? It's listing. Listing what? ls is going to list everything, all the variables that are there in your environment here. Everything, right? So what I'm saying, remove everything. So if I run this, the environment is empty. Okay, I just emptied it because now we are starting in the next part of the thing. So we'll making new variables now. Okay. So okay, so this is something we already saw. Okay. Now we have been talking about true and false, right? So like we discussed, which is going to take in a list of trues and false, right? Now, if also takes in, so the values inside of if should also be true or false. Okay, so that is important. It can be a single true, it can be multiple. We'll see how it evaluates those, but it needs to be true or false only, not any number, not any character, not any's, nothing. So let's take it the simple way. So I have, let's say A is 4. Now I'm asking, if I evaluate only this thing, the one that's inside the bracket, what is it going to tell me? It's going to say, yeah, that's true, right? So if I say, so what does if do? It says that if whatever condition you have given inside, whatever expression is there, if it evaluates to true, that means if the output of the inside function, right? Again, this is an expression. This is actually evaluating something. It's not explicitly a bracket, but this is giving you an output, right? What output did it give you? It gave you true. So now if the inside of if is true, you do what is written between these curly brackets. So curly brackets are used to define blocks or chunks. Okay. So here we are defining a chunk, and this chunk will only be executed if this expression evaluates to true. If this expression a less than 5, if this evaluates to true, then you go to this chunk. So if you see what R does is, it goes line by line, right? It goes through this line, next line, next line, next line, and so on. But this line here is only going to be evaluated because this line is within this curly brackets. This line will only be evaluated if the if function here gets true. Okay, so, and how are you supposed to run these? You are supposed to select the whole thing. If you're doing it in RStudio like this, you should select the whole thing. You can also run it just at the starting also. If my cursor is here and I press Control Enter, you see the whole thing got copied. And you remember some of you had got this plus sign initially when you were starting off with R. So the plus sign indicates that you have a multi-line command and it's a single command. Now you see this whole thing is one thing. It is spread over 3 lines, but this is one thing itself. This is the complete chunk. And this chunk is defined by these curly brackets. Okay. So now what happened here? Since A is 4 and 4 satisfies the condition that 4 is less than 5, R will go into this chunk and it will do whatever the chunk says. The chunk says print yes, so it will print yes. Good. Now, if A is 9, if I change the value, and if I run this whole thing, it does not give me anything because I never specified what to do if this condition is not satisfied. I just said, if the condition is satisfied, do this. If the condition is not satisfied, don't do anything. That's what it means. So it did not do anything. Nothing. Is this clear? Yeah, just yes, no. Because now it's going to get slightly complicated. Okay, I'm assuming it's clear. All right. So now, so it's rather than not having anything, it's good to, I mean, sometimes it's mostly good to have the other alternative also, right? So in these cases, there are only two options. A number can be less than 5 or it may be not less than 5. These are the only two conditions, right? Less than 5 or greater than equal to 5. That's how you can say it, right? So this is what I'm saying. If this condition is true, you go to this chunk, this thing. Else means if not, if this condition is not satisfied, you go to this chunk, right? So let's try if we have 4 here. And now if I put, now see, I have my cursor here. I put this here, the whole thing is executed. So if that happens, it's going to give me yes, because that's correct. But now if I have 9, and if I execute the whole thing, it gives me no. Now I'll just tell you how to write this. This is important. So I've written if. Now you see, if is a recognized term, right? So it changes color. If you have that condition formatting done, otherwise not an issue. And I put a curved bracket. Now R, if you enter the first curved bracket, it automatically gives you the second closing curved bracket. But if it doesn't, you always write it on yourself. So here I'll write A less than 5. That's okay. I come next to it, and on the same line, with or without a space, that's your choice, you need to write the curly bracket. This is important, same line. And you can continue on the same line also, but it's slightly clearer if I press enter. Now you see what happened here was, you see, now by default, my cursor is here. It's slightly shifted away from the margin. Okay, so this is called, it's like a tab here. You see this tab button right above caps lock on your keyboard. So this is what R automatically does. It's just, this does not have any effect in the evaluation, but it just makes it clearer. So what I did here was, I had the curly bracket here, I pressed enter. The second curly bracket came even one line below, and I got my cursor here. Now here I'll write print bracket and double quotes. I'll write yes. That's what I've written here. Now since I would like to extend it, so again, with or without space, I'm writing else. And then I again open the same bracket. Now this else has to be in the same line as this bracket. This is also important. And then the starting bracket of else also has to be in the same line. And then I press enter again to get the chunk for else. Same thing happens. The closing bracket goes below 2 lines and I get a cursor in the line below. And here I can just write print and no. So this is how I've written it. Yeah, I'll just remove this because so that it's not confusing, but yeah, this is how I've written it. Any questions? Clear, right? Okay. So, okay, what have I written here? Multiple. Yeah. So, now by default, if and else, the simple if and else, it only would want one value, right? Because how would you, if I'm giving it a list, so let's say, let's try that. So this is my list B, and can you tell me what is this going to give me? B less than 5. What is the output? Are you all asleep? Tell me something. You're all there, right? You can just put it in the chat box. If it's confusing, please let me know. I'll explain. Yeah. Okay. Thank you. Yes, it's going to give me true, false, false. That's correct. Because it's just comparing B and 5, right? So it's giving me true, false, false. That means the input for if and likewise for else, it is true, false, false. So if I run this thing, it says error in the if condition. The condition has length greater than 1. Okay. So this gives an error. And can somebody remind me what is the difference between error and warning?
Error won't give result, but warning gives a result.
Correct. That's right. Yeah. So here it's an error. The command did not run. It did not give you any result. Okay. So if and else. So we'll see. So yeah. So if this is only if and this is if else, these are not designed to handle multiple trues and false together. So it gives an error. Okay. Now, so we cannot give it multiple elements like that. But what we can do is we can give it multiple conditions with single elements. So let's try this. If I say D is 8, so I have two evaluations here. D greater than 5 and D less than equal to 9. These are my two evaluations. Now, can you tell me if I combine these two evaluations with an AND, what is this going to give me? True and true. And true gives a true, right? So since this whole thing evaluates to true, it is a single true. So it can be given as an input, and this is going to give me a yes, right? Because this evaluates to true. So it goes into this chunk. It will not go into this chunk. Never will it happen that both the chunks are going to get executed. That is important, right? Because if else ensures that only one of them is possible. If takes in some part of the universe, else takes in the other part of the universe. And by universe, I mean all possible values, right? Likewise, now if I have D 0, so this evaluates to false, this evaluates to true. So false and true, you remember what that's going to give you from the AND gate? False, right? So here, if I evaluate this, this is going to go into the else chunk. So I'm going to get a no as the output, right? So that's also done. Now, further going into some if else statements. Now, here I would just like you to be a little careful. So this is a good way. This is actually a recommended way of doing it when you have multiple statements within the chunks. what I mean is, this is a statement within the chunk. This is the chunk. By chunk, I mean the curly brackets. And anything, so here you can write multiple lines, right? You can write print q. You can write a is equal to 9, print a. I can write multiple lines here. So let's say I have d is 8 and I'm printing this. So you see, all of this got printed. Whatever was there within, everything got printed. Everything got worked actually. So a, you saw there's a new variable here and so on. Now, now the thing is, but if you just have single small things to be written, you don't have to make it so complicated. There is a slightly simpler way to do it. And this is the if else. If else without any space. If else is a function. It's like this. Normally what you have is, if is that function, right? And it's like this. If, or it's if and else, but here it's if else. So how this is done is, if else takes 3 parameters. The first one, or 3 arguments. The first one is the condition. This thing. This is the first argument. Second argument is what to do if it's correct. Third argument is what to do if it's false. Okay. So likewise, so yeah. So if I say, so let's say I'll evaluate this one to d is equal to, let it be 8 for now. So this one is going to give me true, right? So if I evaluate this, it's going to give me yes. Now, do you remember what the double AND stood for? Okay, so right now for single elements, for single trues and false, double and single AND is the same thing. So I will just skip over that for now. And I would like you to see what is happening here. The only difference is I've written print in front of yes and no. So now you see what happened is, same condition, everything same, but now it also evaluated, like it gave me yes twice. So yesterday, or like 2-3 days back when I was trying this, I was not sure what is happening. So let's see if you can figure it out. Okay. I think I've understood what is happening here, but I would like to have your confirmation as well. So now you see this one here. So here we were just checking with a single true. If else can handle multiple values, unlike if else. Multiple values, I mean multiple, a list of true and false. So if I'm specifying a as 1 to 10, and if I'm writing this simple thing, a greater than 6, yes for trues and no's for false. Can you think what it's going to give me as the output? So basically, if I wrote, so a is this, right? If I am writing a greater than 6, it's this. That's right. Now I'm specifying this additional thing, that if else, and you're feeding this thing, yes and no. Any idea? Is it getting too complicated? False gives no. So yeah. So true gives yes. That's absolutely correct. So if I'm running this, you get a no everywhere there was false, and you get a true everywhere. You get a yes everywhere there was true. Now I'll run this thing again. So where I've explicitly said print. Now you see what is happening here. Now you see this one. Can anybody tell me what do you understand from this thing? These things here. Just this part. First it prints whatever we said. Yeah. and then it does if else. Correct, right? So actually, just a slight modification. It prints whatever of these, what happened here? 1 second. Is there a way to switch on a pen when I'm sharing the screen? Okay, this one. Yeah. Yeah. So now you see what happened here actually. So here we got just true as the output. So it goes into the true slot and it just prints the whatever was said here, and then it evaluates the function and prints that. So anyway, so it's doing a double thing when we explicitly mention print. I have not been able to exactly understand why the function does it, what functionality it holds, but I would just like to tell you this, that do not use print inside of if else, the combined one. Okay, so if else can handle multiple trues and false, but this is something you need to be careful with. Okay, I tried figuring it out that why it does so, but I'm not sure. Okay, but don't do that. Okay, all right. So now coming to one more step complexity. Since it can handle multiple values, let's see how it handles and double AND. So I have A here and I have B here. They are both of the same length. They are both vectors with the length 10, so that we do not get warnings and errors because of the length thing we discussed. Remember, when it's comparing, it does an element-wise comparison. So I have this thing, A greater than 6, and then I have this thing, B less than 10, B less than 20. Okay, so this has false, 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 false. The first 6 values are false and the last 4 values are true. And here the first 9 values are true, the last value is false. Okay, so now if I do AND here, simple AND this thing, so it's going to take in, it's going to give me 10 results, and it's going to give me a true only when both the first expression and the second expression, when both of them evaluate to true. So false and true gives false. Here likewise, then this true and this true gives us true. The next 3 elements are giving us true, and the last one, true and false, gives us false. This one's fine, right? Now instead, if I do it this way, a double AND, do you remember what it's going to give us? So what it does here is it actually it's taking in the 2 values, the first 2 values, it's evaluating it just the way it should, but that's it. Okay, end of story. It takes the first value of this expression, it takes the first value of this expression, it does AND on it, and it stops. First prints whatever we said, then it does if else. Yes. So here I was just explaining these 2 things first, just for ease. So now in this case, basically this function is a list of 10. This expression is a list of 10. Right? So if I enter, so it will work as per this expression, right? This expression, you'd see false, true. These trues evaluate to yeses and the false evaluates to no. But now here in the last one, this is actually just a single value false. So here it's just going to evaluate to true. And this gives you a warning, right? This is the same warning. This warning is not coming from if else. This warning is coming from this double AND. Okay. Warning is from and. Warning is not from if else. because if else just needs if it gets a list, it's going to evaluate it as a list. If it gets a single value, it's going to evaluate as a single value. Okay, so which is why I will recommend that you should always use AND wherever possible, because if it's a single value, that AND works well for single value, and if it's a list, it will work for a list. So AND is always a better option. Yeah. Okay. All right. Now we come. I think this is one of the major last things for today, and we're probably going to exceed time. So sometimes you would like to have an if else condition within an if else. It's possible you would like to take a sub condition. So yeah, so a double AND means that a double AND is only for a single value. Okay, now this AND here, yeah, this way. So this AND works for both single and multiple values, right? But a double AND, it works only for single values, and it considers the first element if multiple are given. That's what we just discussed. Okay, so since single AND works for both the cases, it's good. I mean, it serves the purpose, right? You don't have to remember, but you should always know what a double AND does, and this is what the course has taught you, so keep it at the back of your mind. But when you're using right, so like we discussed here, so here d greater than 5 and d less than 9, d is a single number, right? So I used an AND here. Here I used a double AND. It's the same thing. Double AND and single AND will both work correctly for single values, but for increased, for like multiple values, it's recommended you should only use a single AND. So it's just, so what you just wrote here, so we should use an AND and not a double AND. This is like when you use it in reality, but for the course point of view, you are taught both of them, so remember both of them. Okay, all right. So then we come to nested condition. So now let's say I am interested in, so I have these 4 numbers with me. Okay, and I am interested in, I want to check if A is I want to compare, I want to see if A is less or more than 5. And for B, I want to check if B is less or more than 20. Let's say these are the 2 things I'm interested in. So what are the options? That maybe A is satisfying the condition, or maybe I'll just write this less than. Okay. Multiple values means multiple trues and false, and evaluates trues and false, right? So this one, for example, these are multiple values. B also here is multiple values. So if I'm doing an AND on this, so I'm basically saying false and true, that's the first element. False and true, that's the second element. Likewise, true and true, that's the 7th element. Likewise, true and false, that's the 10th element. So if I run this, I am getting 10 elements in this. But if I have only double AND with me, what does this evaluate to? This takes in the first element of my expression on the left against this thing. And for B less than 20, for this thing, it also takes the first element. It does AND on the first two elements. So it does false plus true, which gives false. This false, same thing. And that's the end of it. It doesn't proceed. Okay. So now, let's say this is what I'm interested in. I want to check if A is less than 5. I want to check if B is more than 20. Now, it's possible. So I'm calling it condition 1. And I'm calling it condition 2. So now what this indicates is that, so now you can think about 4 possibilities, right? That 1 and true are both satisfied. Or you can say, and by 1, I mean condition 1. I don't know, this is how I write condition, right? So condition 1 and 2 are both satisfied. 1 is satisfied, but not 2. And you know the other 2, right? 2 is satisfied, but not 1, and both are not satisfied. Yes, this thing. Yeah. So this means I would like to have multiple of them. So this is one way of doing it. So here it's saying A is less than 5 and B is greater than 2. Both are satisfied. You do whatever you want to write here. Second option here is A is not satisfied, but B is satisfied. Like you've changed the sign of this thing here. Okay. Another option is, so what I've done is if, else, and then I'm continuing it. After else, I'm not just saying not of the first condition. I'm saying if the first condition is not satisfied, I would like to split the remaining field into some more parts. So after else, normally what we do is, after else, we start this bracket, this chunk. But now after else, we are starting if again. And whenever you write if, you need to give a condition. So now I'm stating one of the second conditions, or I think this is the third condition here. A is not satisfied like what we discussed. So I'm changing the sign of A, but I'm retaining the sign of B. That's the next part. Now, if that is also not met, if it's not that, then I'm saying if, the next if, and I'm saying this is the next condition. Part 3. And then finally, when I say, now this final else, I did not say if because there's only one possibility that both of them are not met. So it means A is greater than 5 and B is less than 20. If both the things are there, then you would print this part. Okay. Now, I would like to give you sort of a, okay. Can I give you 2 homework questions? So these are slightly lengthier questions and it will take a long time. You don't need to write the code for it and you don't need to submit the homework. It's for the next week. So can I run this? Oh, sorry. Okay, yeah, sure. So A is equal to, let's say A is 5 and B is 12. So which one do you think is satisfied? A is equal to 5 and B is, yeah, part 4. That's correct, right? Because this is not satisfied. If I say these two, if I run this one, it's going to give me false, right? If I run this one, this is also giving me false. If I run this one, this is also giving me false. Therefore, it's going to go into the fourth part. So if I run the whole thing, I put my cursor here, I'll run this. It gives me part 4 is the answer. Okay. Now, I will tell you something. Okay, I would like you to, it's not a homework exactly. I will just write something here. And you tell me if it's doing the same task. B is supposed to be less than 5. Then and 1 is greater than 5. Is also greater than 5. So it's here. Okay. Now, can you take a look at this and see what's happening? Okay. Before I go into it, there's one feature that you should explore. So if I put my cursor on near any of the brackets, it's going to highlight its respective closing bracket. This is like the opening bracket. This is the closing bracket. So I put a cursor out here. So this is my chunk. This is my chunk for this if. Likewise, this here, the whole thing, this is a chunk for the corresponding else. Now, what I did was I made a bigger if else, which evaluates only based on A. It does not take into consideration B. But now, within each of the A evaluations, I wrote about B. Now, if A is satisfied, there's an option that B may be satisfied, may not be satisfied. Likewise, when A is not satisfied, it's possible B is satisfied or B is not satisfied. Okay. So, whatever I've written here, this is a continuation of if else, if else, if else. This is actually what is actually called nested if else, where you have if else within if else. Right? These are the smaller if else within the bigger if else. Now, with the same values of A and B, here I got part 4. I should get part 4 here also. So what I'll do, if I have my cursor here, now you see, these were two different things that were evaluated, right? So this was the continuation loop, and this was the nested, not loop, sorry. The continuation conditional statements, and this is the nested conditional statements. They both give me the same answer because they both follow the same logic internally. Take a look at it. I will send you the script. If there's any confusion, we'll discuss it in the next class. But there's one more thing that we need to do. I had also thought of giving you one more question. I'll explain it to you. Again, this is just for your practice to see if you have understood if else. If you're able to do this, it might take you a while. It can take a lot of time. So it's not in your assignment. You can take as much time as you want. But this is just going to give you a better understanding of this. So you all are familiar with what leap years are, okay? So what are leap years? So normally we say leap years come up every 4 years, but whenever it's a century, so let's say if it's the year 2100, which is like some 77 years from now. So if it's 2100, if it is a century, then that number should also be divisible by 4 for it to be called a leap year. You take a look at this logic, okay? So if it's not divisible by 4, if the year is not divisible by 4, you know that it's not going to be a leap year. That's known. But if it is divisible by 4 and it is a century, that means century means it has to be divisible by 100 also. Okay. So yeah, so divisible by 4, but if it's not a century, then you are sure it's a leap year. So the year 2008, 12, 16, 20, and the next year 2024. But if it is divisible by 4 and it's also a century year, let's say 2100, then that should also be divisible by 400. 2100 is not. So the year 2000 was a leap year, but the year 2100 is not a leap year, 2200 not a leap year, 2300 is not a leap year, 2400 is a leap year. So now this is your task. You have to make either of the two forms of conditional statements. They will require 2 or more conditional statements, and you need to make it in such a way that here, whatever value A, you feed it. The tool is going to, it's this part, this chunk is going to return whether it's a leap year or not. Okay. Give it a try. We'll discuss it in the next session. Okay. All right. Now the last two things here. Okay. So now switch takes in multiple arguments. The first one is so the first argument and the remaining arguments, can you explain the nested if else example, the second one? Okay, now you see, okay, so this one is evaluating to false. Okay, that means if this condition is not satisfied, if A is, actually it doesn't matter what it gives me here. So if this condition is true, if A is less than 5, let's say A had the value 0, then you would like to check what is B behaving like. Is B greater than 20 or is B less than 20? So if A is true, let me show it here actually. So now A greater than 5 and less than 5, these were our two conditions, and B greater than 20, less than 20, these were our two conditions, right? So this is how I am writing it. Now it is possible that both the conditions are met. This one means, so this is, let's say, I mean, if the condition is B must be greater than 20 and A must be less than 5. If this is actually the condition that we're interested in, yeah. So, yeah. Right. So what this means here, that A is less than 5, B is greater than 20. And this is what we wanted. This one here means A is less than 5 and less than 20. So A less than 5 is satisfied, but A greater than 20 is not satisfied. Right? So these are the four conditions. These are the four possible options. Now this one I'm calling part 1. I think this one is 2, this one is 3, this one is 4. Okay? Or whatever it was. So now in the first case, I am taking all the four independently. So there was if this was 1, this thing. Then I have else if the second one. Then I have else if the third one. And then I have else, which definitely means it's going to be the fourth one. This is what my first example, the one where we have continued A and A, like if else, if else, if else. Now in the second one, what I did was, if I said A, I think A greater than 5. Let's say this is what I wrote. So that means I am looking at this row here. Now within this row, there are two options. What are the two options? Either this one, where I'm saying that B is greater than 20. Or the other option is else, which basically means B is less than 20. Right? And then I can have else. Actually, what color is left? This one. Then I have else here, where basically I'm looking at this thing. And then I'm going to, let's say, write if B greater than 20, which means I'm looking at this one. Okay. And what color should I use? This one. And then I can have the remaining else. It's not clear. But yeah, this thing. Okay. So I'm first taking only the bottom one, where A is greater than 5. When A is greater than 5, there are two options for B. B is less than 20 or B is greater than 20. Likewise, if A is not greater than 5, if I'm taking this upper row here, then also there are two cases. B greater than 20 or B less than 20. This is what I'm doing here. Is it clear? This is not simple, and I think this was not discussed in the lectures, but these are two ways of doing the same thing, which is why I told you, give it a go, think about it, try to execute it in R. It's going to become much clearer in that. If it's not clear, we will discuss it again. Okay, you have this presentation with you. You will have the R script with you. I'll upload it within half an hour. Okay, so if A is false, then it's basically this else thing. Sorry, this else thing here. Part 2 will be printed for this question. So we have these values here, right? A is 5 and B is 12. So now you think A is 5. So this is false. A is not less than 5. A is 5. This condition only takes in less than values. So we automatically go into else. And then we have B as 12. So this is not evaluated. So we go into else here. If let's say A is 5 and B is 21, then in that case, you'll get part 2. Yeah, okay, all right. Try to understand this one. Also try to understand this. Try to write this thing for the leap years. It's a very interesting thing. It's complicated, but if you do it, you will understand if else forever. You won't forget it. Okay. All right. Now, this thing called switch. So now what switch does is, if you're giving it a list, if you're giving it a vector, after the first argument, then it gives you the value of that vector at the argument that you specify in the first position. So switch can take as many arguments. There's no limit, but the first argument is special. The first argument should be what you're interested in. All the arguments are basically all the other arguments, all the other values, a list. Also, the last element, if there is a last element, it is considered to be a default. Now let's try and see this example here. So here, what I'm giving in the first one in line number 196 is, I'm saying 2, and I'm giving it several values: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So I have 7 values, and I say 2. So 2 basically means give me the value at position 2. So this should give me Tuesday. Fine. Now, let's say instead of 2, I give it 8. So normally the last value is the default value, right? But one second. Okay, yeah. So the last value is the default value, but for that there's a special extra thing needs to be done. So here you get, it's like a no default. So no output. Okay. Now, if I'm doing this thing here, I'm giving it, instead of giving it multiple elements, I am giving it a single list. You remember this is the same thing we discussed in case of mean. You're giving it a list or giving it multiple arguments like that. So if I run this here, this also did not give me an output. 8 gives us no result because there is no default set in this list. I'll tell you why there's no default here. Yeah. So can you tell me what is happening here? Switch by default accepts multiple arguments. It needs to accept multiple arguments. But now what we have done in this example, we gave it just one argument. That means just one value. It is a list that we are feeding it. But all of this is considered to be a single element. Instead of Monday being an element, Tuesday being an element, the whole list, the whole vector becomes an element. And we are asking, give me the value at position 2. But there is just a single element given to it. Does this make sense or no? Maybe this will make it clear. So if I'm running this, I'm not getting an output. But if I run this, I get everything as the output. Right? So 8, there is nothing. So this is position 1, 2, 3, 4, 5, 6, 7. There's no position 8. So I don't get an output. Likewise, here, this whole thing is element 1. Instead of Monday here, this whole thing is 1. So when I run with 1, I get the whole thing as the output. But when I run 2, I don't get any output. Now, a better application of this is when you have named lists. When you have named values. Think of it, so in some languages, I'm not sure which one it is. I think it's Python. Such a thing is called like a dictionary. So you are saying that this value, this name has a value Monday. So day 1 has a value of Monday. Day 2 has a value of Tuesday. Likewise, so on and so forth. Okay. So here, I did not give a name to the last value, which means it's now a default value. Okay. So here what I'm saying is, give me the value of day 4. So this is day 4. So I get a value of Thursday. But now here I say, give me a value of day 8. Yes, Thursday. Give me a value of day 8. So what is this going to give me? There's no day 8. So it goes to the default value. So it says Sunday. Okay. That's what it is. And this thing I think you're already clear with. The which function, we have discussed this extensively today also. You have a vector or a matrix. And so which is actually going to give you the index. So A is 1 to 10. B is this, M is this matrix, this one. So if I say which A is equal to 7, it's going to give me trues and false. So is equal to things, they are always true and false. And which is going to give you the index of trues, right? And likewise, we compare which for this thing. Now here, can you again tell me from our discussion here, this is giving us 3. Why did it give us 3 here? What is 3 with respect to a matrix? Why did this 2 give us 3? Remember? By call 3 element is true. That's perfectly the answer. Now, as one of you had mentioned initially, I forgot to tell it there. We would like to have instead of 3, we would like to actually get what? 1, 2. Because that's what this 2 is at, right? The row is 1 and the column is 2. So there's an argument of which there's this provision in which, where you can write arr.ind, which means array index. If you write true, then you get row 1, call 2. It's a slightly different notation. So it basically tells you that there is one true in your matrix, and this true is at row number 1, call number 2. Okay. So this is what I have. What else do we have? I remember we have to solve some assignment 2 and assignment 3 as well as assignment 4. I'm not sure if we can do that entirely. I just have 2 quick practice questions because we discussed a lot of it in today's class. So These were just 2 questions. Now, do you remember this one? I had asked you, I'll ask this at the end of the class. So X is a vector, 1, 5, 13, 15, any 2, 22. How would you calculate the mean of this vector? So more than one answer is correct here. Do you remember which of the 2 are correct? B and A. No, not B and A. One of A and B is correct and one of C and D is correct. That I can hint. B and D, B and C. That's correct, right? So these 2 are correct. I just wanted to so let's define this thing. In R, so this is our vector X. Yeah, this thing. And mean, this thing gives us 11.2, and this one should also give us 11.2, does it? Yeah. All right. So you're right. Option B and C is correct. Okay, good. And this is just the next question. Suppose X is this vector. Which of the following is the correct output of this? This question I've just given because I think it's very similar to one of the questions you have in this week's assignment. So just to make sure if this if else is clear to you. So you have 12, 4, 16, 8, 20, 5, and 14. Yeah. Now, first step is it's comparing if these numbers are less than 10. Oh, you've done it very quickly. Okay. So is this less than 10? False. Is this less than 10? True. Is this less than 10? False. True. False. True. False. Okay. So for the true ones, you're going to do 2 plus x. And for the false ones, you're going to do 2 multiplied by x. Is that correct? Yeah. Okay. All of you are getting the answer. That's very nice. So for this one, it's false. So I'm going to multiply it by 2. So 24. This is true. So I'm doing 4 plus 2, which is 6. For the one which is false, I'm going to multiply 32. This is true. So I'm going to add 2. This is false. So I'm going to double it. This is true. So I'm going to add. And this is false. So I'm going to double it. So I got 24, 6, 32, 10, 40, 7, 28. So yes, is the right answer. Yeah. Okay, that's it for the session. And this thing, tomorrow is the deadline for the assignment. Now let's see how much we can discuss. First of all, tell me, do you have any questions from assignment 4? Because this one is relatively straightforward. So you have questions like if you do a row sums, what is going to be answer? Call sums, row means, and call means. So the first 4 questions are related. Then if you make a diagonal, you're going to get a diagonal matrix. And this gives you the transpose, right? This you want to multiply. So this is the only sign. And I think we discussed this also in the session. Okay. And if you want to multiply, which same question again, this is that symbol you're going to use. And if you want to multiply it with a scalar, every element gets multiplied by 4. Likewise, you want to add 2 matrices. And here, so this one's an important question. So 3 multiplied by x is not denoted like this, right? This symbol percent asterisk percent is only for matrix multiplication. So this is therefore gives you an error. Next we have correct outcome. So here you want to find the third row. Okay. And here you need to find the first 2 rows and the second, third columns. So it gives you a smaller matrix. And then this one is, how would you get this matrix from the larger matrix? So it's like an opposite question from the first one. And then if you do a C bind of these 2 matrices, what do you get? If you do an R bind, what do you get? And solve, it gives you the inverse, right? So if you want to find the inverse of a submatrix which is formed by this, so you have to read it, like you have to write it opposite. So first, since you want to find the inverse of something, so that something is what you need to make. So first, second, third rows, which is this thing, and second, third, fourth column, which is 2 to 4, you make that. So you write x square brackets, those values, and then you write solve to get the index of that submatrix. Okay, I hope this one's okay. I'm rushing through because these are not very difficult questions. They require you to understand what is being asked, and then also require you to remember how to proceed with it. And then what do we have? So this we discussed, right? You remember the hierarchy of single and single or, double and double or. Yeah. And then this one is, again, this is, we saw some of these like things like this in today. And this one also goes in the same lines. And this is also simple, just simple logical operators. Same goes for this one and this one. And here, this is not equal. So 15 not equal to 45, that's true. 25 not equal to 55, that's true. So all of these are true, therefore all true is that answer. And here they're checking for equality and none of these are equal, so it gives you a false, right? So this is that assignment. Okay, so we've officially, the time is up, but let me quickly go through the questions you mentioned today. Do you last matrix total class, which is this question? Oh, this today's last thing. Oh, right. Okay, wait. Okay, this one. Okay. Okay, I will just explain this. And who had asked the assignment thing today? Yuvashri, would you mind me waiting one more week for the discussion? Because I remember why we have left these questions, and it will not be possible to complete in less time, and we have already exceeded. So since it's not of immediate, like the assignment week, everything has passed. So I will keep this in mind, and I will try whichever lecture we are able to finish off in lesser time, we'll discuss it then. Yeah, and I will search for this log thing because I'm not sure if I know the answer to it yet. I'll get it done before the next session. Will that be okay? I hope you're still in the meeting. Yeah, that's fine. Okay, and for this part, so this is our matrix, right? So matrix is defined with first rows, and then you specify the columns. So now what we are doing here is what I just said that the questions that you had mentioned from assignment 2, 3 and the log thing, it's going to take a while and we have already exceeded the time. So we will do it in one of the upcoming lectures. It's not an immediate thing. So it's important for everybody to understand that. So we'll devote it like at least half an hour in one of the classes. So I have the questions noted with me. I'll get it in the chat of today's meeting, and that calculator thing also. Everything, I will keep it ready with me in whichever class I feel there's time to, there's some scope. We'll discuss it then. Yeah. So I'll just finish off by, okay, Vivek, I'll just answer your first question first. So is equal to 30. This is what we are checking here. So we are checking which of the elements is equal to 30. Now, if I run this, which m is equal to 30, it gives me 3. It gives me 3. So what does 3 indicate? It indicates that the third element, when you are reading a matrix column wise, by default, always, which is going to read a matrix column wise? 1, 2, 3, right? This is 1, this is 2, this is 3. So that's why this gives us 3 as the answer. But this is not very simple to understand. I mean, you need to do some extra mental calculation for this. So there's a better way of getting. So what do we want with this? We want row 1 call 2. This is what the index of 30 is. So if I do this one, array index is equal to true, then I do get that row 1 and call 20. Okay. And the next question is, if x is 1 to 10, take means remainder is 1. What remainder is 1? So I have x 1 to 10 here. Sorry, x is equal to 1 to 10. Can you unmute yourself and ask? Okay. So let me give you an example with this one. So now let's say this is our matrix. And what we can do is, so we are doing m percent, let's say we do it 9. Yeah. So now what this means here is, so when we divide each of the elements by 9, what remainder do we get? So this gives us 1, this gives us 2, 3, 4, 5, 6. That is how the table of 9 works. And now if I want to compare it with 3, let's say I want to compare, or maybe 4, and I run this one. So this is going to give me true, because this is where true is. I'm running whatever you've asked one by one. So first I'm evaluating percent thing. So that gave me this. Right? So that gave me this. Next I'm evaluating, I'm comparing it to a number. And finally, I am comparing it with this thing. So let's say I want to compare, so it should give me, it's going to give me 4, right? And maybe 9 is not the best example then. Let me take a different number so that it's clear. So again, forget what we did here. So m percent 8, right? Because because we are dividing each of the numbers 10, 20, 30, 40, 50, 60 by 8. So it gives us 2, 4, 6, 0, 2, 4 as the remainders. And now I want to compare which of them is equal to 4. So I get these two positions to be equal to 4. And now I want to find the index. Like which positions are these? So I get 2 and 6. Yeah, because 1, 2, 3, 4, 5, 6. And now what we just saw here, we can do array index is equal to true. Can you tell me what should this give me? For this one, I need to get 2, 1. And for this one, I need to get 2, 3 as the indices, right? And when I run this, yeah, so I get it like this. For the first element, it's 2, 1. And for the second occurrence, it's 2, 3. Okay. So I hope that is what you were asking, right? So, okay. So with that, we are done with this. No. Okay. What was it that you were asking? No. Okay. Okay. If it's clear, well and good. If it's not, let me know either in M%, 8 is what? 10, 20, 30%, 8, 2, it is. Okay. All right. So, okay. So this is our matrix M, right? 10, 20, 30, 40, 50, 60. M%, 8 means I am going to find the remainder after dividing each of the elements of M by 8. Right? That's percent. Remember last lecture. Okay. Right? So remainder, then I'm comparing the remainder to 4 and I'm finding the indices, and I'm also finding the indices in terms of the actual row and column. Okay. Yes.
This question, like
Yeah.
you taken.
Can you speak a little more loud? I'm not able to hear you well.
Okay. I'm going to tell them take matrix 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9.
Okay,
Then
wait.
I want the which. I
Okay,
want the
just a second. I'll just write it alongside. So this is 1 to 10. And how many rows, how many columns?
3, 3.
3, 3. So it needs to be 1 to 9 then. Right? So 1 to 9.
Matrix of n row is equal to 3, n column is equal to 3, data is equal to 1:9.
Okay, fine. This is there. That is okay.
The next, then
So
column.
let's. Oh, sorry. What happened? Oh, n row. Yeah, this thing. So this is n, right?
I want value of n,
Value of
which n double percentage 2 is equal to 1. It means
which.
remainder should be 1. What is the how it will become answer? I want.
Oh, okay. So basically, okay. So let's take it.
Which of n double percentage
Double percent 2 equal to 1, right?
double equal to 1.
Huh. This is there, right? Can you see the screen?
Yes, yes.
So what it's
Become
doing.
answer
So the is it?
3, 5, 7.
I hope this is not a question in the assignment, right?
Not.
No, no.
It is in tutorial last
Past tutorial. Okay, okay.
class.
Okay. All right.
Master.
Yeah. So what this one does is, so take it step by step. So n%, 2 means you are dividing each of the numbers by 2 and you're finding the remainder. So basically you'll get a remainder of 1 for the odd numbers and you'll get a remainder of 0 for the even numbers, right? So like this. And then when you're going to compare it to 1, you'll get true wherever it is 1, right? Like this way. And then if you do this, so what we discussed here, which gives you the index, but which for a matrix, which gives you the index when you are reading it column wise. So this is 1, this is 2, this is 3, 4, this is 5, this is 6, 7, 8, and 9. So you are going to get, yes. So wherever this is 1, that means wherever this is true. So it was true at 1, 2, 1, 3, 5, 7, and 9. So this is going to give us 1, 3, 5, 7, 9, as one of you mentioned. Vivek, is that clear?
Yes, ma'am. That is odd numbers are get answer, but how it will become in a generally mathematical method? They are telling it is divided by it is remainder will become 1. That kind of like notebook.
I am not able to understand what became 1.
If I got answer 1, 1, 3, 5, 7, 9. Anna. Then how it will become 1, 3, 5, 7? Like in the way what we are output get input what we are taken in. n percentage to double equal to 1.
This thing,
Yes,
right?
in the place of n, 1 divided by 2 is equal to 1. The remainder,
Oh,
how it will
one
be?
so okay. So okay, I'll just new slide here. So so what we discussed that. So let's take an example of 9 divided by 2 first. So what comes here, it gives you, say, 4. 2 into 4 is 8, and then you get 1. So this is called the dividend. This is called the divisor. This is called the quotient, and this is your remainder. Right? Now, the main thing is that 9 is equal to 2 multiplied by 4 plus 1. That means if I call this D, this I call R, this I call small d, and this I call as Q, dividend is equal to divisor multiplied by quotient plus remainder. This always holds true. Okay. Now, likewise, if I'm dividing 1 by 2, it gives me 0. This is what I get. Now, this is my divisor. This is my quotient. This is my dividend. This is remainder. So 1 is equal to 2 multiplied by 0 plus 1. This is my remainder when I divided 1 by 2. Yeah.
1 by 2 cannot be continued like point like 0.
So when you're doing this now, this is what we discussed in the last time. When this is done, when you're talking about remainder, you do not proceed to decimals. Only then will you get a remainder. If you are going into decimals, you will never get a remainder. That's the idea of going into decimals, right? So let's say you're doing 5 by 2. So this can give you 2.5. But what we are interested in here is this thing. Right? Okay.
Yes, ma'am, got it.
All right. Okay. So, okay, I think that is all we had. We will discuss the remaining assignment 2 and 3 questions and the log thing. Hopefully we'll get time in the next class, but yeah, okay, that is all. And thank you for sticking up until so late. All right. All the best. If you have not done the assignment yet, the deadline is tomorrow. And all right. Good night then. Bye-bye.